In 1968, beneath a rock cliff in Montana, a chance discovery changed everything we thought we knew about the first Americans. Construction workers digging in a gravel pit near the small town of Wilsall unearthed something extraordinary: a small skeleton, buried with ceremony and intention over 12,000 years ago. The remains became known as Anzac I, named after the family who owned the property. But this wasn't just another ancient burial. This child was laid to rest with the unmistakable markers of the Clovis culture, the mysterious people who once roamed Ice Age America with sophisticated stone tools and hunted now extinct giants. He's the only human remains ever directly tied to Clovis. His genome is the only one ever recovered from a Clovis individual and among the oldest full genomes from ancient Americans. But what his DNA revealed would do more than connect us to a lost culture. It would rewrite the entire story of how the Americas were first peopled. The Clovis culture takes its name from Blackwater Draw, an archaeological site near Clovis, New Mexico, where distinctive stone tools were first identified in the 1930s. These weren't crude implements, they were works of art. Exquisitely fluted spear points, carefully knapped from high-quality stone with a characteristic channel running up each face. The fluting made the points easier to attach to wooden shafts and may have improved their penetration into thick-skinned prey. Clovis points date to a narrow window of time, roughly between 13,000 and 12,600 years ago. They've been found across the North American continent from coast to coast, often in association with the bones of mammoths and mastodons. Kill sites, places where Clovis hunters brought down megafauna and butchered them for meat, hide, and bone. These people lived during a pivotal moment in Earth's climate history. Around 12,900 years ago, the planet was warming after the last ice age, when suddenly temperatures plummeted again. The Younger Dryas, a cold snap that lasted over 1,000 years. Glaciers advanced, ecosystems collapsed, and across North America, the great megafauna began to disappear. Mammoths, mastodons, giant ground sloths, saber-toothed cats. Within a few centuries, they were gone. The Clovis hunters faced this catastrophe. Their way of life, built around hunting massive animals, was under siege from a changing world. For decades, archaeologists believed they had the story figured out. The Clovis first model dominated thinking about the peopling of the Americas. According to this theory, Clovis represented the very first human inhabitants of the continents. They arrived via the Bering Land Bridge, a now submerged connection between Siberia and Alaska that existed when sea levels were lower during the Ice Age. These pioneering people moved south through an ice-free corridor between massive glaciers, burst into the Great Plains, and rapidly spread across two continents. It was a neat, linear narrative. Clovis first, the original Americans. But the long, dominant Clovis first model of initial settlement via the Bering Land Bridge began to crack. And the child buried beneath that Montana cliff would be the one to shatter it completely. The discovery site at Wilsall was actually a double burial. Two individuals were uncovered in that gravel pit, labelled Anzac I and Anzac II. But only Anzac I was suitable for scientific study. Anzac II's remains were too fragmentary, too degraded. Anzac I, however, was remarkably preserved. With him were approximately 125 artifacts: Clovis points, bone tools, antler implements. Some of the stone tools were stained with red ochre, the same iron-rich pigment found on the child's bones. He had been wrapped in hides, his tiny body dusted in red ochre, a mineral that carries profound symbolic weight in cultures around the world. And then he was laid beneath the tools, deliberately, carefully. The arrangement wasn't random. Radiocarbon dating fixed the burial at 12,600 years ago, right at the end of the Clovis period. This child lived during the final generations of Clovis culture, possibly witnessing the decline of the megafauna his people had hunted for centuries. But here's what makes this burial so extraordinary beyond the artifacts. Someone loved this child. Someone grieved. The red ochre, the careful wrapping, the placement beneath valuable tools, these weren't practical acts, they were ritual, spiritual. An expression of loss and hope. Perhaps a belief that the child would need these things in an afterlife, or that his spirit needed to be honoured, protected, sent onward with care. 12,600 years ago, a community stood on this spot and said goodbye. And in doing so, they left us a message they could never have imagined. The remains were stored at Texas A&M University for decades. They sat in collections, occasionally studied, but never subjected to the cutting-edge genetic analysis that would later become possible. Ancient DNA technology didn't exist when the child was first discovered. The very concept of sequencing DNA from bones thousands of years old seemed like science fiction, but by the 2010s, everything had changed. Next-generation sequencing had revolutionized genetics. What once took years and millions of dollars could now be done in weeks for a fraction of the cost. And most importantly, researchers had developed techniques to authenticate ancient DNA to distinguish genuine genetic material from modern contamination. A team from Texas A&M and Montana State University, working alongside Sarah Anzik, daughter of the property owners who had discovered the burial, decided to revisit the child's remains. They extracted DNA from a fragment of bone and subjected it to the most rigorous analysis available. The authenticity checks were crucial. Ancient DNA is damaged in characteristic ways. Cytosine deamination, a form of chemical degradation that happens over millennia, leaves a distinct molecular signature. The Anzik child's DNA showed all the hallmarks of authenticity. This was genuinely ancient genetic material, not contamination from modern handling. And when they assembled the full genome, they realized they had something unprecedented. One of the first complete ancient North American genomes ever recovered. A chance to answer questions that had puzzled archaeologists for generations. Who were they? Where did they come from? And most critically, what happened to them? What the genome was about to reveal would overturn migration theories that had stood for half a century. Maternally, the Anzik child carried haplogroup D4H3. In genetics, a haplogroup is a family of related genetic lineages that share a common ancestor. Mitochondrial haplogroups, inherited exclusively through the maternal line, are particularly useful for tracing ancient migrations because they don't recombine. They pass from mother to child largely unchanged, accumulating small mutations over time that serve as molecular clocks. D4H3A is a rare lineage today. When it appears in modern populations, it's more common along parts of the Pacific coast, among coastal communities, groups with maritime traditions and deep connections to the ocean. But here it was, 12,600 years ago, found inland, hundreds of miles from the nearest coast. That was a problem for one popular theory about how people first entered the Americas. The coastal migration hypothesis suggested that the first Americans traveled down the Pacific coast by boat, hugging the shoreline, exploiting rich marine resources. They moved quickly, the theory went, island hopping and beach camping their way from Alaska to South America, while the interior remained locked in ice. But if D4H3A was a coastal lineage, what was it doing in the Montana interior during the Clovis period? Had coastal groups already pushed inland by this time? Or did the coastal migration route and the interior route happen simultaneously, with different populations using different strategies? The child's maternal lineage was raising more questions than it answered. But the real revelation was still to come. Paternally, the Anzik child was QL54, a Y chromosome haplogroup. This lineage represents one of the founding American lineages, a genetic branch that split from its closest Asian relatives around 16,900 years ago. That date is significant. It places the divergence right around the time people would have been moving across Beringia, the land bridge between Siberia and Alaska. QL54 and its related lineages are found almost exclusively in Native American populations. They're a genetic signature of the peopling of the Americas, carried by men who crossed from Asia and whose descendants spread across 2 continents. But the real bombshell came when researchers compared the Anzik child's full genome to modern populations using sophisticated statistical methods. Outgroup F3 statistics, a technique that measures shared genetic drift between populations, showed that the child shared the strongest connections with dozens of Native American groups, not just a few. Dozens. And when they dug deeper into the data, they found something extraordinary. The Anzik child's genome indicated direct ancestry to many, possibly up to 80% of present-day Native Americans, especially in Central and South America. Groups like the Caritiana of Brazil and the Maya of Mexico and Central America showed particularly strong genetic ties to this 12,600-year-old boy from Montana, 80%. Let that sink in. A Clovis child from Ice Age Montana was a direct ancestor to the vast majority of indigenous people across 2 continents. His lineage didn't die out. It exploded, it diversified, it became the primary genetic current flowing through the Americas for thousands of years. But if 80% of Native Americans trace ancestry to Clovis, what about the other 20%? That's where the story gets more complex. The genome revealed a deep split among Native American populations that began before Clovis. Not everyone descended from the same ancestral group. Many northern groups, communities like the Cree, Ojibwa, and Algonquin, traced to a slightly different branch, a lineage that had diverged earlier, possibly representing a separate migration event or an earlier splitting of populations after entry into the Americas. This wasn't a simple story of one group entering the Americas and spreading out. It was layered, multiple streams of ancestry, multiple founding populations, or perhaps a single founding population that split very early, diversifying rapidly as people moved into new territories and adapted to different environments. The 20% outside the Anzac child's direct line hinted at additional complexity, at chapters of the story still waiting to be discovered. Other ancient genomes, other burials, other windows into migrations we don't yet understand. But one thing was abundantly clear from the data. There was no European affinity. None. For years, a fringe theory called the Solutrean hypothesis had suggested that some of the first Americans might have come from Europe. The theory pointed to superficial similarities between Clovis points and Solutrean stone tools from Ice Age Europe, proposing that ancient Europeans had crossed the Atlantic along the edge of sea ice, bringing their technology to the Americas. It was always a controversial idea, contradicted by most archaeological evidence. But now, genetics delivered the final verdict. The Anzac child's genome showed no European connection whatsoever. Zero. No support for the Solutrean hypothesis. Instead, the data showed clear links to Siberia. When compared to ancient genomes from Eurasia, the strongest connection was to a 24,000-year-old individual from Malta in south-central Siberia. The Malta child, found near Lake Baikal, carried ancestry that contributed to both Europeans and Native Americans, a population that lived before those groups diverged. The Anzac child's genome confirmed what archaeology had long suggested: Asian ancestry entering the Americas, people moving from Siberia, across Beringia, and into the continents. Not Europeans, not Atlantic crossings, the Pacific route, the Bering Gateway. So if the genetics proved an Asian origin, what does that tell us about when people actually arrived? Because here's where the Clovis first model completely falls apart. Archaeological sites across the Americas tell a story that predates Clovis by thousands of years. Monteverde in southern Chile dated to approximately 14,500 years ago. That's nearly 2,000 years before Clovis. And it's not just one or two sites. Pre-Clovis evidence keeps accumulating. White Sands National Park in New Mexico preserves fossilized footprints, human tracks pressed into ancient lake sediments. The dating is controversial, but multiple lines of evidence place them between roughly 21,000 and 23,000 years ago. If those dates hold up, people were walking across North America during the last glacial maximum, when ice sheets were at their maximum extent. So if people were here before Clovis, what was Clovis? Not the first Americans, that much is certain. But perhaps something more interesting. A cultural fluorescence, a technological innovation that spread rapidly across the continent, a shared tool tradition that linked distant communities. The Anzac child's genome suggests that Clovis people were part of the main ancestral stream that led to most modern Native Americans. They weren't replaced, they didn't vanish. Their descendants are alive today, speaking hundreds of languages, maintaining thousands of distinct cultural traditions, but sharing a genetic heritage that traces back through millennia to a boy buried with red ochre beneath a Montana cliff.